Hey everybody, Mr. Odom here, and I am going to work through some problems from section 3.2. You'll need your pencil, composition book, or a notebook paper to take notes. You might need a calculator, and the learning target for this video is that you can apply properties of operations to add linear expressions. So in the lesson video, we talked about what a linear expression is. It basically is an expression where the variable is raised to the first power. All right, so we basically want to be able to add linear expressions together. In this video, I will make another one where we will practice subtracting linear expressions. So there are two different ways to add linear expressions. One is called the horizontal method, the other is called the vertical method. And so for each of these three problems in this video, I will work them out both ways. If you get a little confused, you may want to pause the video after I work out one of the problems a certain way if it seems confusing, or replay it. So this video might be a little long. I apologize for that, but this is such an important skill that I want to try to go slow and give you as much detail as possible. So with that, let's get started. Remember, we have these steps that we're going to use to simplify our expressions, and these steps will still come into play as we work through these problems, especially when we use the horizontal method to simplify or find the sum of our linear expressions. All right, so without further ado, problem 8. So in the horizontal method, let me just write this problem down. N plus 8 plus n minus 12. So what I'm looking to do first is see if I can get rid of these parentheses. Notice that there is no number in front of, or an expression in front of these linear expressions. So because there isn't anything in front, then I can go ahead and just drop the parentheses. So I can write this as n plus 8 plus n minus 12. So notice the parentheses are gone. I can identify the like terms, which is what we've been practicing in the previous section. We practiced quite a bit. And so I'm identifying the like terms. I can put those like terms together, which is something that we've also done before in the previous lesson. And I can go ahead and combine these terms. So n plus n is 2n. Positive 8 minus 12 is negative 4. Then I ask myself questions. Are there parentheses? No. Are there any like terms? No. So this expression is in simplest form. All right, so that is the horizontal method. It pretty much looks similar to what we did in section 3.1 when we were simplifying expressions. Let's look at this in the vertical method. So in the vertical method, let's see, I might need some space here. Let me write the problem down again. N plus 8. And what I'm doing is I'm adding the other expression, which was n minus 12. So n minus 12. Okay, so I'm adding vertically, just like in elementary school when you would add things like this together, right? So that's what we're doing here, these linear expressions. So the question still that I need to answer is can I drop the parentheses? Well, again, there's no value in front of the linear expression, so I can go ahead and I can drop the parentheses. N plus 8 plus n minus 12. Okay. All right, so this is an addition problem. So now I can go ahead and I can line up. There's my like terms. They are already lined up, and I can go ahead and combine them. N plus n is 2n. Positive 8 plus negative 12 is negative 4. Okay, so some students like using this vertical method instead of the horizontal method. Either one works, you get the same answer. So I leave it to you to figure out which one might be simpler for you to use. Which one do you feel more comfortable using? All right, now let's go back up here and let's look at problem 12. So in the horizontal method, I write this down 5 times negative 3.4k minus 7 plus 3k plus 21. And I want to know, can I drop the parentheses? Well, if I look, there is a number that's in front of this linear expression. So I need to use the distributive property for this linear expression. Here, there is no value in front of this linear expression, so I can go ahead and I can drop the parentheses. So let me do that for this part. I'll just put the 3k plus 21. But here I'm going to use the distributive property. So 5 times negative 3.4k is negative 17k. And 5 times negative 7 is negative 35. So notice now I have this expression that looks similar to what we did in section 3.1. And I can identify my like terms. Those are like terms. All constants are like terms. I can put them together. Negative 17k plus 3k. So there you go. Negative 35 plus the 21. So here are my like terms. And I can go ahead and combine them. So negative 17k plus 3k is negative 14k. And negative 35 plus 21 is negative 14. All right. Are there parentheses? No. Are there any like terms? No. So that has been simplified. All right. So now let's look at this problem using the vertical method. So I have 5 times negative 3.4k, and that was minus 7 plus, and I had 3k plus 21. All right. Again, I want to be able to drop those parentheses. Can I do that? Well, I can see here that there is a number that's outside the parentheses, which tells me, hey, use the distributive property. And once I do that, then I can drop the parentheses just like I did when I went from this step to this step. So I can do that here as well. So 5 times negative 3.4k is 17k, and that's negative because a positive times negative is negative. 5 times negative 7, negative 35. And I'm adding to that. Again, there's no number in front of this linear expression, so there's no reason to do or use the distributive property. I can go ahead and drop those parentheses. So I have 3k plus 21. So now I have negative 17k plus 3k, and that is negative 14k. Then I have negative 35 plus 21, and that is negative 14. So I get the same answer. There's no parentheses, there's no like terms. Again, notice how when I use this vertical method, how it's easy to see the like terms. They're all lined up nice and neat. and I can combine them. All right, so let's look at one more problem. And this one, horizontal method. So let me write this down. I have negative 1/2 times 7z plus 4 plus 1/5 times 5z minus 15. So the horizontal method, notice there are values here in front of these linear expressions. So I'm going to use the distributive property. Okay, negative 1/2 times 7z is negative, whoops, let me put that in purple again, sorry. I've been using purple the whole time. I'll continue. So negative 7/2 z, and I have negative 1/2 times positive 4, and if you do the work, you'll see that that is negative 2. Then I have positive 1/5 times 5z. Notice I included that positive. So it's positive 1/5 times 5z, which the 5's cancel, and that is just positive z. And then 1/5, positive 1/5 times negative 15 is negative 3. And then from this part, I can go ahead and find my like terms. There's like terms there, and these are like terms here. I can go ahead and combine them. And I do want you to get to the point where you can just identify the like terms and combine them here. So let's try this. Negative 7/2 z plus z, which I can write that as 2 over 2 z, because 2 over 2 is just 1, and 1 times z is just z. So this becomes negative 7 plus 2 over 2, and all of that is multiplied by z. Okay? So I've combined this term and this term and this term. And now negative 2 minus 3 is just negative 5. All right, and we can go ahead and combine the numerators here. Negative 7 plus 2 is just negative 5 over 2, or negative 5/2 z minus 5. All right, so that is how we can simplify this expression. Those of you that like mixed numbers, you can change the negative 5/2 into negative 2.5 if you want. You don't have to. Both answers are good. There's no parentheses. There are no more like terms. These are in simplest form. Okay, let's look at this one more time using the vertical method. Negative 1/2, and then this was z, whoops, z, I messed that up. That is 7z plus 4, and then I'm adding to it 1/5 times 5z minus 15. Okay, so let's go ahead and work the problem vertically. Again, I need to go ahead and use the distributive property just like I did above. So let's do that. Negative 1/2 times 7z is just negative 7/2 z. Negative 1/2 times positive 4 is just negative 2. And then 1/5 times 5z is just z. And then 1/5 times negative 15 is negative 3. And remember, I'm adding these linear expressions together. The parentheses are gone. Again, remember, if there is no coefficient in front of the variable, I could always put a 1 there. And then I can always write 1 as a fraction. to help me out. And that's what I'm going to do here. I'm going to write it as 2 over 2. Okay, and now I can go ahead and I can combine my like terms. And negative 7/2 z minus 2 over 2z is just negative 5/2 z. Negative 2 minus 3 is negative 5 again, or you can write this as negative 2.5 z minus 5. All right, so longer video. I usually don't like these videos to be this long, but I felt it was important to show you the different ways that you can get to the same answer using the vertical method to find the sum of linear expressions, or the horizontal method, which is something we've been doing already. So this is Mr. Odom. I hope this was helpful. Again, if you have questions, don't hesitate to ask. And I am out. You guys have a good day. You're awesome.